So let us see how to solve the transportation problem. Okay, we have obtained the optimal solution for the following transportation problem. So transportation problem has got the data regarding the goods transporting from the factory to the stores. So the values that are there inside the matrix, which is nothing but F1, F2, F3, constituting the row S1, S2, S3, S4, which shows the column, are going to be the matrix that denotes the cost value. So this is the cost matrix. And regarding these goods, the number of units that are going to be supplied, on the other hand, number of units that are going to be demand are given as 3, 7, 5, 4, 3, 4, 4. So we always take care that the total supply is equal to total demand, such that when total supply is equal to total demand, we call it as a balanced transportation problem. So to find the optimal solution, or to find a solution for any transportation problem, has got two stages, two parts. Part 1, to find the initial solution. Then we proceed with this initial solution to part 2, the optimal solution. We are going to denote the supply, the total supply and the total demand by summation AI and summation BJ. So to start with, because our summation AI is equal to summation BJ, is nothing but the value 15, adding up 3 plus 7 plus 5, 15, as well 4 plus 3 plus 4 plus 4 is also 15. So our observation is summation AI equal to summation BJ equal to 15. So we are given with balanced transportation problem. So for this balanced transportation problem, first we are going to find the initial solution. To find the initial solution has got three methods, namely north-west corner rule, least cost method, and Vogel's approximation method. So here for this problem, we use Vogel's approximation method. In short, it's written VAM. We use Vogel's approximation method for the distribution of, for the allotment, for the allocations of the supply and demand, which is given by 3 dash 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 3 4 1 3 1 dash. So let us see whether this initial solution is a basic feasible solution. When do we call this initial solution as a basic feasible solution? Whenever it satisfies the expression number of allotments in this allotment table is equal to an expression m plus n minus 1. So let us see how many allotments we have in this allotment table, in this initial solution. So allotment table is nothing but the initial solution. What we have is only also called as allotment table. Let us check how many allotments are available in this allotment table. So 1, 2, 3, 4, 5, 6. We have 6 allotments. Whichever the cell the values are allotted, they are counted to be the respective allotment. Whichever the cell is blank is said to be unallotted. So we have totally 6 allotments. So number of allotments equal to 6. Find the value of m plus n minus 1. M means number of rows in the problem. N means number of columns in a problem. So in our problem, F1, F2, F3, there are 3 rows. So we have m is equal to 3. And there are 4 columns, S1, S2, S3, S4. So n is equal to 4. So this will give us m plus n minus 1 is 3 plus 4 minus 1, that is 6. So our observation, number of allotment is equal to m plus n minus 1. Number of allotment value and m plus n minus 1 values are the same. Whenever this number of allotments and m plus n minus 1 are same, we will call that solution as basic feasible solution. So this expression is satisfied for the initial solution. Therefore, this initial solution is called as initial basic feasible solution. So because it is going to be initial basic feasible solution, we will now proceed for the test for optimality. That is to find the optimal solution, which is part 2 of our solution. So optimality test is going to be conducted for so far obtained initial solution using the method called modified distribution method. So this modified distribution method has got the following step. Step 1, we are going to prepare a table for all these allotted cells that we have in our part 1. Wherever we have allotment, for this allotment, we are going to prepare one new table such that in that new table, wherever the allotment value is obtained, instead of allotment value, we should write the cost value. What do we mean by cost value? Cost value means it is a value that is given in our problem. So every cost value in general denoted by Cij. So what are we going to do? We are going to prepare, this is step 1. We are going to prepare a new table for our initial solution. For this initial solution is nothing but the allotment table. So whatever the allotment is available in the initial solution, in that place, instead of writing the allotment, we are going to write the corresponding cost value. So that is what step 1 says. Prepare a table with Cij for the allotted cells. So to start with, in our allotment table, the first allotment value is 3. So we will not write 3. In the place of 3, what is our corresponding cost value in the problem? 2. So we write 2. We write 2. So the next allotment table, dash, dash, dash. No allotments. So here also we put dash, dash, dash. Second row, first 2 cell, no allotment. So dash, dash. Third value is 3. Instead of 3, the cost value. In the place of 3, we have 5. So we put 5. Next allotment, 4. In the place of 4, our cost value is also 4. So we put 4. Third row, in the place of 1, in my question I have 7 as cost value. In the place of 3, in my question I have 6 as cost value. In the place of 1, again I have cost value 6. The last one is dash. So I put 7, 6, 6, dash. So this is what the new table, which is going to be step 1 in my optimality test, such that we prepare the table of this initial solution with cost value Cij. After that, we denote every row of this new table in terms of U, every column in terms of V. Because we have 3 rows, we call first row as U1, second row as U2, third row as U3. And because we have 4 columns, first column as V1, second V2, third V3 and fourth V4. So immediately forming this new table with all cost value for the allotted cell, we are going to denote every row by the notation UI and every column by Vj. Next step in our optimal solution. We are going to form an equation for the previous step 1 table as ui plus vj equal to cij for every occupied cell. That means wherever we have allotment in this step 1 table, wherever we have allotment to the corresponding cell, we frame an equation with respect to u and v. So, say to start with, the first allotment value, the allotment available, the occupied cell is 2. The cost value is 2. For this cost value 2 corresponds to u1 row and v1 column. It lies in first row and first column. This cost value, the first cost value 2, lies in the first row denoting by u1 and first column denoting by v1. So we will get in the form of an equation as u1 plus v1 is equal to 2. So this is what we have written as the first equation. u1 plus v1 equal to 2. Now the next occupied cell we find in the second row, whose value is 5. The cost value is 5. So 5 corresponds to the u2 and v3. So our equation will be u2 plus v3 equal to 5. The next occupied cell has got the cost value 4. Therefore 4 lies for u2 and v4, which gives the equation u2 plus v4 equal to 4. Then u3 plus v1 equal to 7, u3 plus v2 equal to 6, u3 plus v3 equal to 6. So this is our step 2. Forming an equation of the form ui plus vj equal to cij for every occupied cell. So we form this equation. Because we had 6 occupied cells with the cost value, we have the corresponding 6 equations. So for our understanding, let us denote this set of equations by asterisk. So here we find all our ui and vj are constants. Let us find the values of all the constants. So in order to find all the constants, we are going to fix one of the variable as 0. Assume one of the value, either ui in terms or vj in terms, makes as a 0. So how are we going to do so? So we look in our step 1 table, which of the row altogether or which of the column has got more number of allocations. So to say, the first row has got only 1 allocation, second row 2 allocations, third row 3 allocations. Likewise, first column 2 allocations, second column 1 allocation, third column 2 allocation, last column 1 allocation. So altogether, which either a row or column have got many allocations. So we come to know the third row on the whole has got 3 allocations, which means u3 has got maximum allocation. Because of this, we assume u3 as 0. We put u3 as 0. So the moment we assume u3 as 0, so what do we say? Assume the maximum allocation either from row or a column to 0. In our problem, the third row has got 3 allocations, that is maximum number of allotment. Therefore, we put u3 is equal to 0. So in my asterisk set of equation, wherever I have u3, the moment I put u3 as 0, we get here v1 equal to 7, v2 is equal to 6, and here v3 equal to 6. So when we put u3 equal to 0, it gives v1 value 7, v2 value 6, and v3 value 6. Subsequently, substituting v1 value, v2 value, v3 value in the other equations, we will be able to get, when I substitute v1 equal to 7, I arrive u1 is equal to minus 5. When I put v2 is equal to 6, or to get u2 value, when I put v3 equal to 6, we get u2 is equal to minus 1. Likewise, v4 is equal to 5. So we find substituting these values in the above asterisk equation, we get u1, u2 and v4 also. This completes step 2. Step 2, forming an equation with respect to the previous step 1 table occupied cost value. After that, we fix one of the maximum allocation to 0. Correspondingly, we find the other values. Once we find the value of every variable, we are going to put it around the pencil in the previous table, so that it will be helpful for the following step or calculation. So we found u1 value minus 5. So we put in bracket beside u1 minus 5. u2 value we found minus 1. u3 value we got 0. Like that. v1 value we got 7. v2 value we got 6. v3 value we got 6. v4 value we got 5. So we write down the corresponding values of these constant aside, so that this will be helpful for the next step. Because step 3 of our optimal solution is to prepare the next table with an expression called ui plus vj for unallotted cell. So getting back to our step 1 table. Wherever in step 1 table there is no allotment, in such places add up the corresponding u value and v value. So wherever it is an allotment, we are going to find the new value. Wherever we have allotment, we make it as a blank space. So to start with, in my new table, from step 1, there is an allotment in the first value. We make it as a blank. Wherever we have allotment in step 1 table, that becomes blank space. Wherever there is no allotment, we are going to add up the corresponding u and v value. So in step 1, the first value is allotted. So here I make it as blank space. The second value in step 1, it is a unallotted. So for that unallotted, add up the corresponding u and v. So this goes to u1 minus 5 and v2 6. So difference of sign when you add 6 minus 5 is 1. So we write 1 here in the new table. Again, the third cell, it is an empty cell in step 1. Wherever it is empty cell, add up the corresponding u and v. Again, minus 5 plus 6 is 1. So we write 1 in the new table. Then going ahead, the same row, the last cell is again unallotted. Adding up the u value minus 5 and v value plus 5. Minus 5 plus 5 will become 0. So I should write 0. This completes the first row. Likewise, we come down to the second row of the step 1. So again, second row, first cell is unoccupied, adding up the U and V. 7 minus 1 is 6. Next is also unoccupied. 6 minus 1 is 5. Next two are occupied. Occupied will become blank in the new table. Unoccupied, we found the value 6 and 5. Like this we do for the third row. Third row in step 1 table, first 3 already has got occupied allotment over there. The cost values are there. So wherever I have already allotment, I make it as a blank space in my new table. And wherever it is unallotted, there is a blank space unallotted in step 1 last row. Add up the corresponding U and V. 0 plus 5 will become 5. So this is how we get the next step. Preparing a new table with U and V, adding up U and V wherever I find unallotted in step 1 table. After this, we proceed to step 4, which is going to some new computation using the formula Cij minus Ui plus Vj. This computation is denoted by delta Ij. We are going to calculate something called delta Ij. It is given by the formula Cij. What do we mean by Cij? Whenever we say Cij, it is always a cost value from the given problem. Minus of Ui plus Vj. Where did we find Ui plus Vj? In the previous step, step 3 table. So, wherever I found this Ui plus Vj, the corresponding values are now should be subtracted from the cost matrix from the given problem. Okay. So, now to start with the new table, the first one is a blank space. So, in my step 4, the first one will become, the new table also will become blank space. The next value I have 1 as Ui plus Vj. So this 1 is now subtracted from my given cost value. 1 and 2 are subtracted. Cij minus, so 2 minus 1. 2 minus 1 will be 1. The next value 1. So 1, what is the corresponding cost value in the problem? 2. So 2 Cij minus, so 2 minus this 1 is again 1. So next value is 0. So this is Ui plus Vj 0. What is the corresponding cost value in this place? 1. So subtracting 1 minus 0 is 1. Like that, second row. Second row we have the value 6. Ui plus Vj is 6. Now this 6 is subtracted from the cost value 10. Because Cij minus, so 10 minus 6 is 4. Then 8. 8 minus 5 is 3. Then 2 are dash dash. So here also I put dash dash. Third row, I have previous step dash, dash, dash. Here also dash, dash, dash. Then I have a Ui plus Vj as 5. Subtracting this 5 from the original cost value 8. Cij minus, so 8 minus that 5 will give you 3. This completes my computation of delta Ij. What is delta Ij? In the previous step, wherever we have found the values of Ui plus Vj, wherever the values are present in the previous step, subtract these values from the corresponding cost value from the question. After which, we have to check whether every value in this step 4 is only a positive number. Is that all my values in this step 4 or every value in this? So this every value is called as delta Ij. So delta Ij takes up the value 1, 1, 1, 4, 3, 3. We should check whether all these delta values are greater than or equal to 0. If so, the optimal solution is reached. Otherwise, if at least one of the value we come to know it, if we come across a negative quantity less than 0, then optimal solution is not reached. So in our example, in step 4 table, delta ij has got every value is a positive number greater than 0. Therefore, optimal solution is reached. So we come to it. So since all our delta ij is greater than 0, optimal solution is reached. So we come to know our initial solution, which is considered for the test of optimality, is now become an optimal solution. So we conclude by saying initial solution is called optimal solution, and we have to write down, we can write down this optimal solution in a separate table. So what should we write below this optimal solution? Whatever we got this initial solution, that put into test for optimality and gave all our delta ij value as a positive quantity. Hence, this initial solution becomes the optimal solution. So let us write down the same allotment table that is there for initial under the optimal table. So optimal solution is given by the same 3 dash 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 3 4 1 3 1 dash, and getting the corresponding transportation cost. How to find the transportation cost? Multiplying every allotment in our optimal solution with a corresponding cost value. So we do 3 corresponding cost values 2. So 3 into 2. Then second row, 3 corresponding cost value is 5. 3 into 5. Then 4. 4 corresponding cost value is 4. 4 into 4, 16. Like that, 1 into 7, 3 into 6, 1 into 6. Adding all these product will give our answer 68. So this is going to be the solution, the final solution, optimal solution for the given transportation problem.